about the preparation properties. Today we will see about here preparation of the haloalkanes. Preparation of haloalkanes. Okay, so preparation of haloalkanes and haloarenes also. Okay, now we will check it out the preparation of the haloalkanes. How we can prepare the haloalkanes? Actually, before going to this one, I want to tell one thing. So if you are seriously preparing for any competitive examination, means as per my knowledge, organic chemistry is little bit easy while comparing with the physical and inorganic. Is it right or wrong? How many members you know about this one? While comparing with the other chapters, either physical or inorganic, organic is very easy.
Yes, sir.
So why I'm telling that organic it is easy means here repeated reactions only it is there. Okay, now whatever the reactions we studied in 11th standard hydrocarbons chapter, again same concepts only we are getting. So there we studied about the chemical properties of the hydrocarbons. By using the chemical properties of the hydrocarbons, again we are using in the preparation of the haloalkanes. Sir, what are the properties we studied in the hydrocarbons in 11th standard means here? Halogenation reaction.
For halogenation.
Very good, Aditi. It is one of the best method here. Okay, simple one is which easily we know here. If you take from alkanes, means here, first reaction is halogenation reaction. Halogenation reaction. Okay, in halogenation reaction, which one are involves means here only alkanes are involved in a halogenation reaction. Okay, which one is involved in the halogenation reaction? Alkanes are involved in a halogenation reaction, and halogenation will take place at allylic position and benzylic position. So clearly, I'm telling that alkanes are involving. That means alkanes are having sp3 hybridized carbon atom only, na? Okay,
yes, sir.
Are having sp3 hybridized carbon atom only, and allylic carbon also it is having sp3 hybridized carbon atom only. Benzylic carbon also it is having sp3 hybridized carbon atom only. Okay, so that's why so allylic carbon, benzylic carbon, alkanes are it undergoes to the halogenation reaction. Okay, so generally we can say, sir, alkanes are stable inert at room temperature, but changing the reaction condition. So they form as a product. Okay, so what is meant by the halogenation reaction means here? So when the alkanes are treated with chlorine in presence of sunlight or UV light, it forms as a mixture of products. Okay, for example, to make you clarity, first of all, I'll explain the halogenation reaction. What is meant by the halogenation reaction means when alkanes are reacts with halogens. When the alkanes are reacts with halogens. For example, what is the best example we are taking means I'm taking as a methane. Simple example of the alkane is methane. What is the molecular formula of the methane? CH4. Okay, if the CH4 is reacts with chlorine in presence of sunlight or UV light or at high temperature at high temperature. At high temperature, if it is treated means it forms as a mixture of products. Sir, what are the mixture of products we'll get means based on the number of hydrogens. For example, if you remove the one hydrogen means you will get as a methyl chloride CH3Cl. If you remove the two hydrogens means it forms as a dichloromethane CH2Cl2. If you remove the three hydrogens means CH3CHCl3. And if you remove the four hydrogens means it forms as a CCl4. It forms as here CCl4. Methyl chloride, dichloromethane, chloroform, and carbon tetrachloride. All these are the mixture of products are going to be formed in the halogenation reaction. Okay. If you want to study deeply means here, first of all, halogenation reaction, it follows the free radical reaction mechanism. Free radical reaction mechanism. Free radical reaction mechanism. How many members you are having idea about the free radical mechanism? Do you have any idea about the free radical mechanism? First of all, what is known as the free radical? Aditi, Kathy, Samhita not yet joined us today. Ritu, what is mean by the free radical?
Sir, it is formed after homolytic or heterolytic
Very good,
reactions.
very good, Aditi. Okay, so free radicals are formed by the homolytic cleavage. Okay, how they're forming means here, they formed by the homolytic cleavage. Okay, by the homolytic cleavage of the covalent bond. Okay, it forms as a free radicals. Sir, what is meant by the free radicals means here? The atoms or molecules which contains odd number of electrons is called as a free radical. Free radicals are paramagnetic in nature. Okay, free radicals are paramagnetic in nature. Sir, where we studied about all this one means here reaction intermediates. While studying the GOC, we studied some reaction intermediates. Sir, what are the reaction intermediates we are having means free radicals are there, carbocation is there, carbene ion is there, carbenes are there, benzene is there, nitrene is there. So all these are the reaction intermediates. All reaction intermediates are highly unstable. They are highly reactive. Okay, so carbocation and carbon ions are obtained by the unsymmetrical cleavage of the covalent bond. Free radicals are obtained by the symmetrical cleavage of the covalent bond. Now got the clarity? Okay, now anyway, once again, I'll explain the mechanism. So there we didn't discuss about the mechanism here. So first of all, halogenation reaction, it follows here. Which mechanism is free radical reaction mechanism. And if you see, sir, which alkanes are the reacts? Okay, so reactivity of the alkanes. Reactivity of alkanes. Okay, so reactivity of the alkanes. So which alkanes are more reactive? Actually, we have a different types of the alkanes are there here. So primary carbon, secondary carbon, tertiary carbon. Okay, all of you, do you have any idea about the primary, secondary, tertiary here?
Yes.
Okay, so what does it mean here? What is the primary? What is the primary? Samhita, what is the primary? Left. Samhita left. What is the primary, ma? Any one of you?
Sir, it's around
If the carbon is
Anyone? Kathy.
It has 3 hydrogens
It has 3 hydrogens. That's not the
and
correct
one other element. And as
the primary is like the hydrocarbons are the halogens are attached to one carbon, primary, two carbons, tertiary, and three carbons tertiary and two carbons secondary.
Very good, Ritu. Ma here, primary means, let us see. First of all, I'll explain the primary carbon, secondary carbon. Here, CH3 bonds, CH3 it is there. Now, so let us consider it as a carbon. This carbon is attached with neighboring. How many carbon atoms are there? Neighboring, how many carbon atoms are there for this carbon? 1.
so it's primary.
Then it's primary. The carbon which is attaches to the one neighboring carbon atom is that we can call as a primary. Okay, and CH3 bond, CH2 bond, CH3. The carbon which is attached with the neighboring 2 carbon atoms is called as a secondary. Okay, and tertiary. CH3 bond, bond CH3, bond CH3, bond H. The carbon which is attached with the neighboring 3 carbon atoms is called as a tertiary. Okay, now let's see. Once again, I'll explain here. The carbon which is attached with the neighboring only 1 carbon atom is called as a primary. The carbon which is attached with the neighboring 2 carbon atoms is called as a secondary. The carbon which is attached with the neighboring 3 carbon atoms is called as a tertiary. Okay, now, so primary hydrogen, secondary hydrogen, tertiary hydrogen. Again, in that only they are giving classification. So we are talking about the reactivity. Which reactivity we have to check it out means, so reactivity of the hydrogen because of whatever the halogenation reaction it is there. So free radical substitution reaction. Actually, what is the complete name of the reaction means here? Free radical substitution. Okay, substitution. Sir, what is meant the substitution means? Highly reactive element is displaces with the less reactive element here. Okay, that is only we can call as substitution. Or one atom is replaced by the another atom in that we can call as a substitution. If you clearly observe the product and reactant, in reactant total, how many hydrogen atoms are there? In reactant total, how many hydrogen atoms are there?
4.
4. In that one, we are getting as a different product. Sir, how we are getting as a different products with by the replacement of the chlorine atom. Okay, now first one, if you see means one hydrogen atom is replaced by the one chlorine. Second structure, 2 hydrogen atoms are replaced by the 2 chlorine atoms. Okay, third structure, 3 hydrogen atoms are replaced by the 3 chlorine atoms. Fourth one, 3 hydrogen atoms are replaced by the 4 chlorine atoms. Sorry, 4 hydrogens are replaced by the 4 chlorine atom. That means it is the displacement reaction only, na? Displacement reactions are called as a substitution reactions. Okay, now which one is going to be replaced means hydrogen. First we have to find out the reactivity of the hydrogen. Okay, now here 3 hydrogens are there: primary, secondary, tertiary. So which hydrogen is more reactive?
The third one?
Third one, very good one. So tertiary is more reactive than secondary. Secondary is more reactive than that of the primary. Okay, if you take reactivity of hydrogens, if you take reactivity of hydrogens means tertiary hydrogen is more reactive than secondary hydrogen. Secondary hydrogen is more reactive than primary hydrogen. Okay, now you got the clarity. Still anyone you having doubt? Okay, so clear. And which alkane is more reactive means tertiary alkane is more reactive than secondary and tertiary also we can say. Okay, and next point. So what is the next point means here? Reactivity of the halogens. Reactivity of halogens. Reactivity of halogens. Sir, we have a different types of the halogens now. So any one of you can tell me?
Fluorine is the highest.
Ma?
Fluorine is the highest in the reactivity.
Okay, ma. Fluorine is greater than. Next.
Chlorine, bromine, iodine.
Bromine, iodine. Okay, so from chlorine to iodine, reactivity order is going to be decreases. So why the reactivity order is going to be decreases? Any one of you?
Sir, electronegativity.
Electronegativity is decreases.
Iodine is also a good leaving group.
Ma, Samhita is giving some answer.
Iodine is also a good leaving group.
Good living group. Okay, iodine also it is a good living group here. Okay, now in this one, let us say whenever we are taking the halogenation reaction. Okay, so here fluorination does not take place. Fluorination does not take place. So why the fluorination does not take place means it causes
No, because it is too violent.
too violent. Okay, so violently reacts with the alkanes. Okay, so fluorination reaction is so highly violent. Okay, next chlorination. So chlorination reaction is slow reaction. So this reaction we can takes place in presence of sunlight. Bromination reaction is very slow reaction. Very slow reaction. Okay, and bromination reaction also it is very slow reaction. It is also very slow reaction.
And sir, it is also reversible, right?
Right, Mahia. Okay, so very slow reaction and it is a reversible reaction. It is reversible reaction. Okay, so actually iodination reactions are carried out. Iodination reactions are carried out in presence of strong acids. In presence of strong acids. So what are the acids we are taking means iodic acid, HiO3 and HNO3. So what are the acids we are using for the iodination reaction? In iodination reaction means here the reactions are carried out in presence of HiO3 and HNO3. Sir, why we are using the reaction in presence of strong acids means first of all, so when the alkane is reacts, first of all I'll explain the iodination reaction, but then we'll go for the next step here. Okay, so because of here we have exception case here, that's why I'm going to be explaining here. The remaining total we can clearly explain by the mechanism. Okay, so first one is we got the clear. So what is the here? Fluorination reaction is violent. Fluorination reaction is violent here. That's why we can't take place here. And we have a possibility only chlorination and bromination. And iodination also cannot be take place. Sir, why the iodination reaction cannot be take place means here, for example, methane is there. If the methane is reacts with iodine, it forms 2 moles of the methyl iodide, 1 mole of the methyl iodide plus hydrogen iodide. In this one, whatever the hydrogen iodide it is forming, it acts as a reducing agent. Act as a reducing agent. Again, it reduces the methyl iodide here. Again, it reduces the methyl iodide. Okay, and if it reduces the methyl iodide means again it forms as an iodine molecule. So due to that reason only, to overcome this reaction, whatever the product it is formed, so that again it is reacts with the strong acid. For example, 5 moles of the hydrogen iodide it is formed. That 5 moles of the hydrogen iodide is again it is reacts with HiO3. HiO3 means it forms here 3 moles of the iodine molecule plus 3 moles of the water molecule is going to be. 3 moles of the iodine is going to be formed and 3 moles of the water molecule is going to be formed. Now you got the clarity? So why the reaction is carried out in presence of strong acids means because of it forms as a hydrogen iodide. Hydrogen iodide it acts as a strong reducing agent. Again, it reduces the methyl iodide into methane into iodine. To overcome that one, the reactions are carried out in presence of strong acids. When the hydrogen iodide is reacts with strong acid, it forms as iodine plus water molecule is going to be formed. Now you got the clarity, everyone? Okay, so any doubt is there? So this is the exception case for the iodine here. Then what are the remaining are there? So now let us see directly chlorination reaction. So chlorination reaction we can see about the mechanism also. Okay, reaction mechanism. Reaction mechanism. Actually, free radical reaction mechanism is going to be completed into 3 steps. Free radical reaction mechanism is going to be completed into 3 steps. What are the 3 steps means here? Chain initiation, chain propagation, chain termination. Okay, how many steps we are using? 3 steps. What are the 3 steps means here? Chain initiation, chain propagation, chain termination. In this one, first step, chain initiation. Chain initiation. Chain initiation. Okay, sir, what is meant by the chain initiation? What happened in this reaction means any two.
Homolysis of chlorine.
Very good, ma. In chain initiation process, we can observe the homolytic cleavage. Okay, we can observe homolytic cleavage. For example, chlorine molecule. So chlorine molecule is containing how many chlorine atoms? All halogens are monoatomic or diatomic? All halogens.
Diatomic.
Ma?
So they are diatomic.
Diatomic. All halogens are here diatomic. So that means they'll exist in the form of X2 only. That means F2, Cl2, Br2, I2 only. Okay. Now Cl2 means this we can write as a Cl bond, Cl only na. Okay. And this one my question is, Kathy, in the formation of the one bond, how many electrons are involving? In the formation of one bond, how many electrons are involving? Kathy?
Sir, I think 2.
2 electrons. Very good answer. Okay, how many electrons are involving in the formation of covalent bond means 2 electrons are involving. Okay, sir. So which bond means covalent bond? What is meant by the covalent bond, Samhita? What is meant by the covalent bond?
Shared pair of electrons.
So here mutual sharing of electrons between 2 atoms is called as a covalent bond. And what is meant by the homolytic cleavage, Ritu? Homolytic cleavage. Now we are using some word. Homolytic cleavage. Ritu.
I'm not sure, sir.
Aditi? Aditi, what is mean the homolytic cleavage, ma?
Sir, in that the shared electron goes to both of the atom after breaking the bond.
Okay, ma. Sir, simply what we can say is symmetrical cleavage. Symmetrical means equal distribution of electrons. Now you are telling that, so formation of one covalent bond, 2 electrons are there. Now in between the chlorine, how many electrons are there? Means 2 electrons are there. Okay. What is mean the homolytic cleavage? Means symmetrical cleavage. Symmetrical cleavage means equal distribution. So whenever you distribute the electrons equally to the 2 atoms, okay, so that time each chlorine atom is contains 7 electrons. Okay, contains here 7 electrons. 7 electrons. Is 7 is the odd number of electron or even number of electron, ma?
Odd.
Very good.
Odd.
Odd number. So what I'm telling that the atoms or molecules which contains odd number of electrons is called as a free radical. So in chain initiation process, when the chlorine is exposed to the sunlight or UV light or at high temperature, it undergoes to the homolytic cleavage and it forms as a 2 chlorine radicals. Got the clarity? Next. So one more. And what is another one we had taken? Methane. So methane means I'm writing as a CH3 bond H in between the carbon and hydrogen. Again, we have
So your voice is not audible.
yeah, 1 second. It is now are you able to hear?
Yes, sir.
Yes.
So suddenly power has gone. No problem. Right. So now let us see in this one. Okay. So here this one also it undergoes to the symmetrical cleavage. So when it undergoes to the symmetrical cleavage means, so we'll get as a methyl radical, CH3 radical plus hydrogen radical plus hydrogen radical. Hydrogen is containing only 1 electron. And if we see around the carbon total how many electrons are there means we have a 7 electrons. Total how many electrons are there? 7. 1 and 7 both are odd numbers only, na? Is 1 and
Yes.
7. Okay, so then these two also we can call as a free radical. So free radicals are obtained by the homolytic cleavage. Okay, after formation of the free radical. Second step. What is the second step means here? Chain propagation. Chain propagation. Chain propagation. So what is meant by the chain propagation means? Now here you got as a methyl radical. CH3 radical it is there. Okay, it reacts with chlorine molecule. If this reacts with chlorine molecule means it forms as a methyl CH3Cl plus Cl radical is going to be formed. Once it is formed the product, the reaction is not going to be stopped. That is only drawback in the free radical mechanism. Okay, sir, when the reaction is going to be stopped means until completion of the hydrogen atoms present in a molecule. Okay, until completion of the hydrogen molecule, then only the reaction is going to be stopped. Until that, the reaction is not going to be stopped. The reaction takes place continuously. Okay, now let us see the second step. What happened now? First product you got as here. What is the first product you got? First product you got as a first product you got as here methyl chloride. Now second step we can see. What is the second step means? Whatever the methyl chloride it is, that CH3Cl. Again it is reacts with the chlorine radical. Again it is reacts with the chlorine radical. It is reacts with the chlorine radical means it forms CH2Cl radical plus and HCl is going to be HCl. And what are the CH2Cl radical it is there? CH2Cl radical. It is combined with the one more chlorine molecule and it forms CH2Cl2 plus HCl is the byproduct. Okay, sorry, this one only Cl radical. Cl radical equation is not going to be balanced. Yeah, Cl radical. So one chlorine is going to be attached to the CH2Cl and it forms as a 1Cl radical. 1Cl radical. Now here you got as a one more product. Okay, here you got as a one more product. So like that, your CH2Cl2 plus Cl radical. Again it forms CHCl2 radical plus HCl. Again this one it is reacts with one more chlorine molecule. CHCl2 plus Cl2. It forms CHCl3 plus chlorine radical. Last one. So what is the last step here? Here also you got as a one product here. What is the last step? Again CHCl3 plus Cl radical. It forms as a CCl3 radical plus HCl and CCl3 radical plus Cl2. It forms CCl4 plus Cl radical. Now if you see whole mechanism we got as a different products. What are the products we got? One is the methyl chloride, dichloromethane, chloroform and carbon tetrachloride. Okay, so free radical mechanism in middle of once it forms as a one product means the reaction cannot be stopped here. Okay, so when the reaction is going to be stopped means until the completion of the hydrogens which are present in a molecule. Okay, and what is the last step? So what is the last step in this one means here chain termination, sir. Chain termination. So what is meant by the chain termination reaction means here? Chain termination. So what is meant by the chain termination reaction means any two free radicals are combining together means it forms as a product. For example, if chlorine radical it is there. If two chlorine free radicals are combining together means it forms as a Cl2 molecule. Or two methyl radicals, CH3 radical plus CH3 radical. If two methyl radicals are combining together means it forms as a ethane, CH3 bond, CH3. Or one methyl radical plus one Cl radical is going to be combined together means it forms as a methyl chloride. It forms as a methyl chloride. Note now 1 second. Sorry. So I have some order, that's why I picked the call. All of you are able to hear? All of you are getting my voice?
Yes,
Or?
Yes, sir.
So sorry all muscles, just I have some parcel, that's why I picked the call. Okay, right. Now let us see now. So in this one, what is the exception case for the free radical mechanism means? So free radical mechanism cannot be used. Free radical mechanism cannot be used in industrial sector. Used in industrial sector. Industrial sector. So why we cannot use it as the industrial sector means because it is not possible. Because it is not possible to separate mixture of products into, because it is not possible to separate mixture of products into individual products. Mixture of products into individual products. Individual products. So now you got the clarity? Still anyone having doubt? All of you got the clarity, ma? All of you are able to hear my voice or not?
Yes,
Yes,
sir.
sir.
Okay, so this is about the first step here. So this is the halogenation method. Okay, until here you don't have any clarity, na? All of you are having clarity, na? Don't have any doubts.
Yes, sir. Got it.
Okay, so then can I go to the second method? Okay, now I'm going to the second method. So second method where we are studying means here, second method we are studying from alkenes. From alkenes also we can prepare as a haloalkenes. You know that one? From
Yes,
alkenes.
sir. Addition of hydrogen halides and addition of halogens.
Very good, Aditi. Very good, Aditi. Okay, addition of hydrogen halides from alkenes. So that's why I'm telling that. So why the organic chemistry is easy means here, all repeated reactions only it is there. Okay, so some reactions what we are studying, some chemical properties, that reactions again we are studying under the preparations. What we are studying about the preparation in some chapters we are studying under the chemical properties. Okay, now from alkenes. From alkenes. Okay, from alkenes also we can prepare as haloalkenes. Sir, how we can prepare from the alkenes means, let us see mine. So first one, we are taking as a CH2 double bond CH2. First of all, my question is symmetrical, whether the given alkene is symmetrical alkene or unsymmetrical alkene.
Sir, it's symmetrical.
Symmetrical.
Everyone you are having clarity. So whatever I had given, that is the symmetrical one. Now ethene I had taken. Simplest alkene is I had taken as a ethene. Okay, so when the ethene is treated with hydrogen, parcel వచ్చింది తీసుకో parcel వచ్చింది తీసుకో ఫ్లిప్కార్ట్ వచ్చింది బయట ఉన్నాడు ఇంటి బయట ఉన్నాడు. All of you are able to hear ma?
Yes, sir.
Ma, here what I'm asking means here addition of hydrogen halides. Okay, HX directly can I write here either HCl? I will write as a HCl ma. Okay, hydrogen halide. Got the clarity? HCl. For ethene, if you add HCl, it forms as a CH3 bond CH2Cl. CH2 bond CH3 bond CH2Cl. Okay. Now you got the clarity. Still any doubt is there? Okay, how it is converted? Okay, let us see ma. When the hydrogen halide is going to be ionized, it forms H plus and Cl minus ion. Okay, what it is going to form here? When the HCl is going to be ionized means it forms as a H plus and Cl minus ion. Now, in between the carbon we have a multiple bonds. Double bond it is there. In that one is the sigma bond, another one is here pi bond. Another one is here pi bond. If you compare the sigma bond and pi bond, which one is the unstable bond, which one is the stable bond, and which one is the strong bond and which one is the weak bond?
So sigma bond is the stronger one and pi bond is the unstable or weaker one. We can easily dissociate it.
Very good, Mahir. So which electrons are delocalized in this one means here pi electrons are going to be delocalized. When these pi electrons are shifted on this carbon atom, this carbon get as a negative charge and this carbon get as a positive charge. Negatively charged carbon atom is attaches with the H plus ion and positively charged carbon atom is attaches with the Cl minus ion. Now you got the clarity. So if the H plus ion is going to be attaches to the CH2 minus means it is converted into CH3. And CH2 positively charged carbon atom is attaches with the Cl minus, then it is converted into Cl. So finally it forms as a ethyl chloride. Finally it forms as a ethyl chloride. Okay, now I'll give one example. Let us see. So who's going to tell the answer? Cyclohexene. If the cyclohexene is, it undergoes to the addition of HBr. Addition of HBr. So what is the product it forms here? First of all, either the given one is symmetrical or unsymmetrical. First, you tell me that.
Sir, it's symmetrical.
Very good, Aditi. If it is symmetrical, right now, then what is the product it is going to be formed?
Sir, 1-bromocyclohexane.
Very good, Aditi. So what is the name of the product means here? 1-bromocyclohexane. My simple logic. The double bond is present in between the first and second carbon atom. If it is symmetrical, one means any side if you add bromine. Okay, whenever after adding the bromine from there only we can start the numbering. For the substituent, we have to give the least number. So according to that one, what is the product you will get as means here? 1-bromocyclohexane. And the second carbon atom is attaches with the hydrogen. Attaches with the hydrogen. Then only it forms as here 1-bromocyclohexane. 1-bromocyclohexane is going to be 1-bromocyclohexane is going to be. Now you got the clarity. Okay, so all of you clear? Then here, if they had given this kind of structures in the examination, means everyone it is easy to do. Second condition is that. So where is the second condition means? Some unsymmetrical alkenes. For example, if they had given condition 1, CH3 bond, CH double bond CH2. First of all, either the alkene is symmetrical or unsymmetrical.
Sir, it's unsymmetrical because it has extra methyl group.
Yes. Okay, total 3 odd numbers are there. So while having the odd numbers with that, we can call as unsymmetrical. And that is also one side we have a double bond, another side we have a single bond. So it is unsymmetrical one. Okay, we can't cleave it is as a 2 equal halves. So whenever they had given as unsymmetrical alkene, sir, which carbon is attached to the Br minus and which carbon is attached to the H plus ion? That is the question. Sir, how we can
Marconic of Joule, sir.
here?
Sir, Marconic of Joule.
Very good, very good. Samhita is doing Marconic of rule. Samhita, what is meant by the Marconic of rule? Can you please explain?
Sir, when the double bond breaks, the hydrogen attaches to the carbon which has the least amount of hydrogen.
Hydrogen is going to be attaches or bromine is going to be attaches?
So, bromine.
Bromine, because of negative ion. So what is the condition means here? Here, whatever the statement you are giving correct only, but hydrogen with respect to the hydrogen means hydrogen is going to be attaches to the carbon which is having more number of hydrogens in an alkene. Whenever you take with respect to the negative ion means the negative ion is attaches the carbon which is having less number of hydrogen atoms in an alkene. Okay, now sir, what is with the alkene? Which part we can consider means wherever the double bond it is there in a ring, in a open chain compound or in a cyclic ring here, wherever the double bond it is there. So that part only we can consider it as a alkene part. Now I can give the numbering 1, 2, 3. Okay, so 1, 2 carbons only we can consider it as an alkene part. Which one we can consider as alkene part? 1, 2 carbon atoms only we can consider it as a alkenes part. Okay, so whenever it undergoes to the addition reaction, generally we can get as a 2 products. Okay, so generally we can get as a two product. Sir, why we are getting as a two products means here, sir, probability generally we can tell. Probability. Okay, so probability means here, let us see. First option. So when these pi electrons are shifted on these carbon atom, this carbon get as a negative charge, this carbon get as a positive charge. According to that one, negatively charged carbon atom is attaches with the hydrogen. Okay, then we can write as a CH3 bond. This carbon, CH carbon is converted into the CH2. And positively charged carbon atom is attaches with the bromine. Okay, CH2Br. And we have another possibility also. So what is another possibility we are having means here? Let us see. So when these pi electrons are shifted on these carbon atom, this carbon get as a negative charge and this carbon get as a positive charge here. In this one, positively charged carbon atom is attaches with the bromine. Okay, positively charged carbon atom is attaches with the bromine, CH bond Br. Okay, and negatively charged carbon atom is attaches with the hydrogen. Then it is converted into CH3. Then it is converted into CH3. Now, how they're asking the question means, which one is the major product and minor product? When alkenes reacts with hydrogen bromide, what is the major product and what is the minor product?
The second compound is major product, I think.
Very good one. Second
So
one
the
is
second one is major product.
major product. Second one is here major product. Okay. Third one, first one is minor product. So how you're telling that it is a major product and minor product? Any clarity? Ritu, Aditi, Samhita, Kathy. How we can explain whether the given product is major product or minor product? Conversions, this kind of questions only it is there. You have to know. Why you're taking as a 2 bromopropane is the major product? Why not the 1
So
bromopropane?
because it has lesser number of hydrogens.
Aditi, one point you are missing. Let us see. Whenever by shifting of the pi electrons, we are getting as a 2 reactants here. Okay. First, with respect to first, you can add as a H plus electrophilic substitution reaction. Markovnikov rule is it explains the electrophilic substitution reaction. Sorry, electrophilic addition reaction. Sir, what is meant by the electrophilic addition reaction means for the substrate molecule, first electrophile is attaches. First the substrate molecule.
And so because secondary carbon cation is more stable, right?
Very good, Aditi. That is the point. That point I'm expecting from here. Okay, that point I'm expecting you. So because of Markovnikov rule, clearly it explains the electrophilic addition reaction. So what is meant the electrophilic addition reaction means? First the substrate molecule is attaches with the electrophile. Then the reaction is followed by addition of the nucleophile is called as a electrophilic addition reaction. Now in HBr, what is the electrophile? H plus ion only, na? Okay, now I told that two possibilities. First of all, when these pi electrons are shifted in this direction, means this carbon gets a negative charge. Negatively charged carbon atom is, sir, CH3 bond. CH, negatively charged carbon atom is attaches with the H plus, then it is converted into CH2 plus. This is the one carbocation. Second possibility, when these pi electrons are shifted on first carbon atom, we'll get as a one more carbocation, CH3 bond, CH2 bond, CH3 plus. Okay, so in this one, which one is the primary carbocation and which one is the secondary carbocation? Which one is the primary carbocation and which one is the secondary
So
carbocation?
the first one is primary and the second one is secondary.
Very good, Aditi. Okay, first one is the primary carbocation, second one is the secondary carbocation. Okay, if you see the stability order of the carbocations, stability order of carbocations. Carbocation. Which carbocation is more stable means here tertiary carbocation is more stable than secondary. Secondary is more stable than primary. Got it, all of you? Which one is more stable means here secondary carbocation, tertiary carbocation is more stable than secondary. Secondary is more stable than primary. Based on the stability of the carbocations, we are going to find out which one is the major and which one is the minor. Now we got the clarity, all of you. All of you got the clarity or not?
Yes, sir.
Okay. Now I'm giving one question mark. Okay. So shall I make it a previous year question? Okay. First, I'll give one thing here. First of all, one example I'll give you. CH3 bond, C bond CH3, double bond CH2 plus HBr. What is the major product? A and B. Okay. So which one is the major product? Find the major product. Major and minor. So this is the question. So otherwise, how they're asking means, so what is the IUPAC name of the major product? That is also one kind of question. What is the IUPAC name of the major product? Anyone?
So the major product is 2-bromo 2-methyl propane.
Very good, Aditi. Major
And
product is
the
2-bromo.
minor product is 1-bromo propane.
1-bromo propane. Something is missing.
1-bromo 2-methyl propane.
Very good, Aditi. 1-bromo 2-methyl propane is the minor product. Ritu got it? Kathy? Samhita? All of you got the answer or not? Still you are trying. Okay. Now the second question, one more. But you very good, Aditi. Very good. What is IUPAC name of the major product? I'm asking only IUPAC name of the major product. So this one already Aditi gave the answer. Now I'm going to write the structures.
Sir, is it 1-bromo 1-methyl cyclohexane?
Very good, Aditi. 1-bromo 1-methyl cyclohexane. Okay. So first one CH3 bond, C bond CH3 bond Br bond CH3. Second one is CH3 bond CH3 CH bond CH2 Br. Okay. And the second one answer is got the clarity, ma? Still anyone you having doubts? Ritu, any doubt is there?
I didn't get the second ones.
Which one, ma? Which one you didn't get?
The second ones.
Second one, na? Next, Kathy.
I understood, sir.
Samhita.
Understood, sir.
Okay. So I think so, Ritu. Okay. Now I'm going to explain. So I'll write the clear structure of this one here first of all. Ma, cyclohexane means 6 carbon atoms are there. First 1, 2, 3. Here also carbon. 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 It is there. Okay. Now each carbon is satisfied with the tetravalency. That means CH2. This carbon also it is CH2. This carbon also it is CH2. This carbon also CH2. Here also, here double bond is there. Already these carbons are having double bonds. This side one bond, this side one bond it is there. And here it is attaches with the methyl group, CH3 group. And here 1, 2, 3, 4. This carbon is having one hydrogen atom. This is actually complete representation of the given structure. Got the clarity, Ritu?
Yes, sir, got it.
So this is the first position, this is the second position. Okay, so this is the alkene part. According to the Markovnikov rule, at first carbon atom and second carbon atom. So which carbon is having the least number of hydrogens?
The second ones.
Once you check it out. First carbon atom, there is no hydrogens, ma. At first carbon atom, 0 hydrogens are there.
Sorry, sir, I saw the numbering now. First one.
Okay, second carbon is having only 1, 0 and 1. 0 and 1 means least number is 0 only, na? So
Yeah,
that's
sir.
why bromine is going to be attached to the first carbon atom according to the Markovnikov rule. Now you got the clarity. And JEE type of question. JEE type of the question. Let us see how many members do. Okay. So in this one, some condition is that CH3 bond, C bond, CH, CH3, CH bond, CH2, CH3. Major product. I had given very simple structure. Actually, it is a JEE level question. Some condition is there. So what is the condition means here? 1 to shift 1 it is there. 1 to shift. 1 to shift condition is there. Sir, what is meant by the 1 to shift means here? So we can convert the secondary carbocation into secondary carbocation into tertiary carbocation. Tertiary carbocation. We can convert the secondary carbocation to tertiary carbocation. Okay, so how we can convert means by shifting of the either the hydrogen or methyl group or phenyl group. Anything we are going to be shift based on the condition. Based on the condition, we may shift from hydrogen or methyl group or phenyl group also we can shift here. Okay, so that is a condition. So based on condition, what is the major product in this? Otherwise, can I explain first this one? Actually, it is the JEE level concept. Okay, and NEET level also they asked question. So last 2 years back they asked here. So many members they got the confusion. Everyone they thought about here. So bromine is going to be attached to the second carbon atom. 1, 2, 3, 4. So for which carbon atom is bromine is going to be attached? Means everyone they can expect as a bromine is going to be attached to the second carbon atom according to the Markovnikov rule. But that is wrong. But that is wrong here in this one. So why sir means here? So whenever the bromine is going to attach to secondary carbon in second carbon will get as a secondary carbocation. Secondary carbocation. But we can convert the secondary carbocation into tertiary carbocation. So how we can convert means by neighboring carbon atom 1, 2 shift. If the hydrogen is shifted to this carbon atom means this carbon get as a positive charge. So when this carbon get as a positive charge means it becomes as a tertiary carbocation. Tertiary carbocation is more stable than that of the secondary. That's why bromine is going to be attached to the third carbon atom. Can I explain clearly? Any one of you? Can I explain clearly, ma? Step by step?
Yeah, sir.
Okay, right, ma. Let us see. First of all, everything I'll erase here. So this is the structure. So first of all, what is the name of the structure? What is the IUPAC name of the structure? What is the IUPAC name of the structure?
Sir, 3-methyl but 1-ene.
3-methyl but 1-ene Aditi. Very good, Aditi. 3-methyl but 1-ene is the IUPAC name of the structure. Okay. Now Aditi. Now let's see. It is the electrophilic addition reaction. Electrophile means we are adding as a H plus again. Okay. Now when these pi electrons are shifted on this carbon atom, this carbon get as a negative charge and this carbon get as a positive charge. Negatively charged carbon atom is attaches with the H plus. Okay. Now it is attaches with the H plus means it is converted into CH3 bond CH3. Here H it is there, bond CH bond CH3, and this one it becomes as a positive charge. Whatever the positive charge, positively charged carbon here, that is only we can call as a carbocation. Whatever the carbocation we got, that is either primary or secondary or tertiary. First of all, that is my question. Ritu, what are the carbocation it is formed? Either it is primary carbocation or secondary carbocation or tertiary carbocation?
Sir, could you repeat the question answer?
Question mark. So now, so this is the structure we got now. Okay, this is the
Yes.
structure we got. Okay, so in that one, carbocation, whatever the carbocation it is formed, either it is primary, secondary, tertiary.
Secondary, sir.
Very good, Ritu. Okay, now next, Samhita. According to the stability order, in primary, secondary, tertiary, which one is the more stable?
So tertiary.
Tertiary.
Tertiary, sir.
So you're telling that tertiary is the more stable than secondary. That means we have a possibility to convert the secondary into tertiary. So how we can convert means neighboring carbon atom. For example, it is the carbocation. From this neighboring carbon atom, this we are considering this as a first position. This we are going to be considered as a second position. So from the second carbon atom, when hydrogen or methyl or phenyl group is going to be shift, that means if the hydrogen is shifts on this carbon atom, whatever the carbon it gets as again, this positive charge is shifting here. This carbocation is converted to the tertiary or not? CH3 bond, C bond, CH3 bond. Whatever the hydrogen is there, it shifts in the form of hydride H minus. The H minus is going to be attached to the second carbon atom. Okay, and it forms as a positive charge to this carbon. Now in the after shifting, after 1,2 shift, after 1,2 shift, whatever the carbocation it is formed, either it is the secondary, tertiary, or primary. So whatever the carbocation it is formed, either it is the primary, secondary, tertiary. Kathy, which
Sir,
carbocation
tertiary.
will form?
Sir, tertiary?
Tertiary.
Tertiary. Tertiary, very good. No, tertiary carbocation. So according to that, you are telling that so tertiary carbocation is more stable. In the next step, what happened? Bromine is going to be attached to the tertiary carbon atom. Then it forms CH3 bond, bond CH3 bond, Br bond, CH2 bond, CH3. Have you understood? Have you understood here? Okay. Now finally, what is the product you got? What is IUPAC name of the product? 2-bromo,
2-bromo,
2-methyl,
2-methyl butane.
2-methyl. Next, butane. 2-bromo, 2-methyl butane is the major product. All of you got it here? Okay. In case if examination, if you find this answer CH3 bond, CH3 bond, CH bond, CH bond Br bond CH3. If you find, they'll give this answer also. In these two, which one is the major product and which one is the minor product means this is not the major product. This one is the major product. Now you got the clarity. Don't get confused in the examination. So many people after writing the examination, I ask students, sir, it is very easy question. Why you done mistake means, sir, we got confused. We got confused. Unnecessarily we lose the marks and it all they're telling. Got my point or not? Okay.
Yes,
Can I
sir.
give one example
Yes,
to make
sir.
you perfect?
Yes,
One
sir.
example. NEET also it is. NEET also. If you check it out, previous year papers are there. Everyone, if you are reading some previous year papers means in that also this question was there. This kind of question was there. 1, 2, 3. I'm giving one more example to you. CH3 bond, bond, CH3, bond, CH3, bond, CH double bond, CH2 plus HBr. So this is the question. What is the IUPAC name of the major product? That is my question. What is the IUPAC name of the major product?
Sir, 2-bromo, 2,3 okay, sorry, sir. 3-bromo, 2,3 methyl,
3-bromo.
Butane.
Come again.
Sir, 3-bromo, 2,3 methyl, and 2,3 methyl butane.
Somewhere is missing. Aditi, check it out. IUPAC name is missing. But answer is correct only. Assigning of the number you had done some mistake. Once you check it out. You're telling the 3-bromo. You won't get as a 3-bromo.
Sir, it's 2-bromo, right? 2-bromo,
Very good. 2-bromo.
3,3 dimethyl butane.
No, not 3,3. Again, you
Okay,
will say
sir, no,
mistake.
sir. Because of the, I forgot there is no double
Numbering
bonds.
only you
So
had done mistake.
yeah, sir. 2-bromo, 2,3 methyl butane.
That is the correct answer. That is the correct answer. Okay. So is any doubt is there? At least who's going to tell the structure? Just if you tell means I'll write.
Sir,
Ritu,
CH3.
can you tell me the structure? What is the product you did? CH3 bond.
C bond
C bond
CH3
CH3.
bond Br
Then
bond
ma?
CH bond CH3
CH3 bond
bond CH3.
and CH3. Last one is CH2 group is converted into CH3. Now, from where we can give the numbering from left to right, because of substituent has to get as the least number. So whenever you're having the more number of substituent, that time we have to follow the lowest sum rule. 3, 4. So whenever we are having more number of substituents means that time we have to follow the lowest sum rule. Okay. Now according to that one, once you check it out. So what is the IUPAC name means here? Bromine is attaches to the second carbon atom. Then we can write as a 2-bromo, and 2 methyl groups are present at second carbon atom and third carbon atom. That we can write as a 2,3 dimethyl butane. Got it? Got it all of you? So this kind of questions are there in your previous year papers also. So once you practice, if you're having any doubts, you can ask. Okay? Then? Still anyone you're having doubt means now only you can ask. This concept is very, very important for the exam point of view, objective type. You may find out this kind of questions in advanced level also. But advanced level, they won't give us a single step question. Conversions are there. More steps it will be there. But finally, we will get us this kind of the product. All of you got the clarity? Still any
Yes.
doubts are there?
No, sir.
Then can I go for the next concept?
Yes, sir.
Okay. So now we had seen the Markovnikov rule. Then we will go for the anti-Markovnikov rule one day. Okay. So we can go for the anti-Markovnikov rule. Anti-Markovnikov rule. Okay. So anti-Markovnikov rule. Sir, what is the anti-Markovnikov rule? According to the anti-Markovnikov rule, negative ion is attaches the carbon which has more number of hydrogens. Anti-Markovnikov rule also we can call as a Kharash effect. And this also we can call as a peroxide effect. Sir, why we are calling as a peroxide effect means generally the reactions are carried out in presence of peroxide. What are the peroxide we are using means here? Benzyl peroxide, or the reactions are carried out here in presence of hydrogen peroxide, peroxides. Okay, and anti-Markovnikov rule is follows free radical mechanism. Free radical mechanism. Free radical mechanism. Where you studied all these concepts means alkenes chapter only you may study. Okay, and that is also by using the anti-Markovnikov rule, we can add only HBr. Okay, we can add only HBr. For addition of the HBr, only anti-Markovnikov rule is applicable. Okay, others are not applicable here. For addition of HCl cannot be applicable, and addition of hydrogen iodide also is not applicable. Addition of hydrogen, okay, so fluoride also is not applicable. So because of the reactions are carried out in presence of sunlight, which one easily we can break the bond means here hydrogen bromide only we can break the bond to convert it into the free radicals. Okay, and it is not possible for hydrogen chloride, hydrogen iodide, hydrogen fluoride. Okay, so why it is not possible means to cleavage of the hydrogen fluoride, more energy is required because of bond length is less. Lesser the bond length, greater the bond energy. And it has a strong intermolecular attraction forces. You may get the doubt. Sir, according to that, hydrogen iodide is we can break easily. But what happened hydrogen iodide? Hydrogen iodide is it acts as a reducing agent. It is not involved in the addition reaction, sir. Okay. So immediately again it forms as iodine molecule. That's why hydrogen iodide cannot be takes place. So which one only we can takes place in the anti-Markovnikov rule means here hydrogen bromide reaction only takes place. Still any doubt is there? That concept, exam point of view concept. I had seen some question that one. Some paper I had seen. Why hydrogen bromide only takes addition reaction? Why not others? Means these are the reasons. Okay. Then now let us see. So now I will take CH3 bond CH3, double bond CH2 plus HBr in presence of H2O2. What is the product it forms? What is the product it forms?
Sir, will it be 1 bromo, 2 methyl propane?
1 bromo, 2 methyl propane is the correct answer.
So because in anti-Markovnikov rule, the Br will go and attach to the carbon with
Bromine
more
is-
hydrogen.
Yes, very good one. So this is the first carbon atom, this is the second carbon atom, this is the third carbon atom. 1, 2, 3 are there. Okay, so 1, 2, 3. So if you compare with the first carbon, second carbon only, we can consider as an alkene part. Which one? First carbon, second carbon, we are considering this as an alkene part here. Now, according to the anti-Markovnikov rule, bromine is going to be attached to which carbon? The carbon which is having the more number of hydrogen atoms in an alkene. Okay, for which one it is going to be attached means here the carbon which is having the more number of hydrogens. So according to that one, how we can write as here CH3 bond CH3. Okay, bond CH3 double here CH bond CH2 Br. This is the major product. Okay, so in this one is the major product. Sir, why we are taking this one only major product? Why not the others means here? So based on the carbo free radical. So if you see the stability of the free radical, which one is more stable free radical? Tertiary free radical, secondary free radical, primary free radicals are. Which one is the more stable free radical? In primary, secondary, tertiary. Which free radical is more stable?
Tertiary.
Tertiary is the more stable. The stability of the free radicals also tertiary is more stable than secondary. Secondary is more stable than primary. One. Got clarity? Got it? Okay. So stability order also. Now first I'm going to So why first here hydrogen radical. First, it is going to be attached as the Br radical. Br radical. Now we have two possibilities. If it undergoes to the symmetrical cleavage, means either here also we're getting as a free radical, here also we're getting as a free radical. If the bromine is going to be attached to the first carbon, the bromine is attached to the first carbon atom, CH3 bond CH3. So this one you will get as a radical bond CH2 Br. Okay, and second one is if the bromine is going to be attached to the second carbon atom, CH3 bond CH3. Okay, here bond Br bond CH2 radical. So in these two structures, we got as a two structures after adding up the bromine one. Okay, so which one is the primary free radical and which one is the secondary free radical? Which one is primary free radical? Which one is the secondary free radical?
Sir,
the first.
Samita, which one is the primary free radical and which one is the secondary free radical? Kathy, which one is the primary free
so the
radical?
second one is secondary and the first one is primary.
So the second one is primary.
So the first one is tertiary. Then.
First one
Yeah,
is
so the
tertiary.
first one is tertiary. Second one is primary.
Primary.
Second one is primary. Got the clarity, Aditi? Because of radical, tertiary radical means the carbon which is surrounded by the three carbon atoms is called as a tertiary. Okay, the carbon which is surrounded by the two neighboring carbon atoms with that we can call as a secondary. The carbon which is attaches with the neighboring one carbon atom is called as a primary carbon. Got the point? Got it or not?
Yes, sir.
Okay.
Yes.
So which one is the more stable one? Means tertiary is more stable, na? That's why in the next step, the hydrogen is going to be attached to this carbon atom, means it forms as a tertiary carbon here. Okay, that's why we're getting as a major product is this one. Okay, and so I can give one more example to you. Right, man. Yes, one more example. Same example only. Less HBr, but in presence of H2O2. So what is the major product? Or simply to make you convinced, they'll write as in presence of peroxide. In presence of peroxide. Our same structure, two conditions can you tell me, Makia? So one is Markovnikov rule, another one is anti-Markovnikov rule. If it is Markovnikov rule, means what is the product you will get?
So one bromo,
What is the
one. So one bromo, one methyl cyclohexane is according to Markovnikov's rule.
Second one?
So second one is one bromo, two methyl cyclohexane.
Very good, ma. So one bromo, two methyl cyclohexane. This is the structure. One bromo, two methyl cyclohexane. Now all of you got the clarity until here. So this is the major part we are having. For three concepts only we took this much of time because of this is a very, very important. I would like to make you confident. That's why I spent this much of time. Okay, so next remaining all are very easy only. So remaining all are here nucleophilic addition, nucleophilic substitution reactions only we are having one. Okay, so we can prepare the alkyl halides from alcohols also. Okay, clear? Until here, if you're having any doubt, you're not having any doubt now? Do you have any
No,
doubt
sir.
until here?
No, sir.
Then I'll go for the next step. Okay, so these are the three methods from point of view are very, very important. Now I'm going to the next method here. And allylic benzylic carbon atoms. From allylic benzylic carbon atoms also we can prepare as a haloalkanes. Okay, for example, here, for example, if allylic it is there, that means CH2 double bond CH bond CH3 they had given. It is treated with the chlorine in presence of 473 Kelvin temperature. So what is the product it comes here? And one more example also I'll give. Toluene and toluene. Toluene means on benzene ring CH3 it is there. Bond Cl2. It is also treated with so at 473 Kelvin. So what is the product it is going to be formed? Okay, which one? What is the product it is going to be? Now let us see in this one. Let's say this is the allylic carbon atom only, na? And this carbon atom is called as a benzylic carbon atom. So when the allyl and benzyls are treated with the chlorine at 473 Kelvin, the hydrogen atom is replaced by the allylic position and benzylic position. One hydrogen atom is replaced by the allylic position and benzylic position. If the one hydrogen atom is replaced by the one chlorine atom, means it forms CH2 double bond, CH bond, CH2, Cl plus byproduct is HCl. This we can call as here 3-chloropropane. What is IUPAC name of this one means here? 3-chloropropane. 3-chloropropane. And let's see, in this one, fluorine is going to be attached to which one? Either methyl group or benzene ring. Fluorine is going to be attached to which one, ma? In this one, fluorine is going to be attached to the benzylic carbon atom. Okay, benzylic position. So that means at benzylic position, one hydrogen atom is replaced by the one chlorine atom, CH2, Cl plus HCl is the byproduct. Same reaction only if you treat it with NBS, for example, CH3 bond, CH double bond, CH2 plus NBS. What is meant by the NBS? Do you have any idea about the structure of the NBS?
No, sir.
N-bromosuccinamide. So what is the structure means here? N-bromosuccinamide. That means CH double bond, CH bond, C double bond, O, C double bond, O. 1 second. H2, CH2, N1BR. This we can call the NBS. What is the abbreviation of the NBS means here? N-bromosuccinamide. N-bromosuccinamide here. Okay. Now, in this one, what happened? Bromine is going to be substituted at benzyl allylic position. Okay. Bromine is going to be substituted at allylic position. According to that one, how we can write as here? CH3 bond. Okay, CH2 double bond, CH bond, CH2 Br. To make you confused, I'll write one more structure and can you tell me the answer here? Okay, now here it is that given like this. That given like this. Ethyl benzene, CH2 bond, CH3. If it is treated with NBS, okay, NBS 1, 2. Now, bromine is going to be attached to which carbon atom? Either it is the first carbon atom or second carbon atom.
So second, because it has sp3 hybridization.
It is going to be attached to which carbon? First carbon or second carbon?
Second.
No, ma, it's not the second. Second one is the primary carbon. Reactivity order, once you check it out, which hydrogen is more reactive? Tertiary hydrogen is more reactive, na? And if you compare with the first carbon atom becomes as a secondary carbon. Because of this side also phenyl group, this side also methyl group it is there. Got it point or not?
Yes, sir.
Aditi,
Yes, sir.
you got it or not? Okay. So first carbon is more reactive, ma, according to the reactivity order. Reactivity order of the hydrogen. For that reason only first only I had given the reactivity order, ma. Okay. Now it is going to be attached to CH bond Br bond CH3. Don't get confused. All of you don't get confused. Clearly, if they had given this kind of structures, means once you check it out clearly. Okay. Still any doubt is there? Now, again, one more structure to make you perfect. Ritu. Let us say here. Give a chance to her give the answer. Ritu CH bond CH3 bond CH3. I'll give the numbering 1, 2, 3 plus NBS. NBS. It is not the CH2, it is the second carbon atom. Otherwise, we'll change the number. Color of the number. Okay. Second carbon atom. Ritu, which here we have 3 hydrogens are there. 1, 2, 3. So 3 carbons are there. So which carbon is it undergoes to the substitution reaction? Ritu.
Sir, is it the
Either
third
first
carbon?
carbon, second carbon, third carbon. Ma?
Is it
Come
the
on.
third carbon, sir?
Third carbon. No, Ritu?
So is it the second carbon?
Very good. Why the second carbon, Aditi? Why not the third carbon? Ritu is telling the third. Why not the third carbon?
So because the second carbon is tertiary while the third carbon is primary.
Very good, Aditi. Ritu, where you're getting confusion, ma? Amma, this one terminal one it is there. All terminal carbon atoms are primary also we can call. Got the point, Ritu?
Yeah, sir, got it.
Okay, so that's why here once you check it out here. Okay, so which carbon is more reactive means second carbon is more reactive than that of the here third and first carbon atom because of it is a tertiary carbon here. So that's why bromine is going to be substituted at second position. Hope so everyone you got. Still anyone you're having doubt means you can ask me. I can explain, no problem, but don't get confused in the examination. Don't lose the marks. Okay, PR because of it is more reactive. Got it? That. Okay. Can I give 5 minutes, 2 minutes break? Otherwise, can I continue? Just check it out your wish. I think so continuously we gone through the class. I want to prepare. I want to complete the preparations today. All of you.
Yeah, sir.
Anyways is fine.
So you need some break.
Yeah, sir.
Aditi?
everything is fine.
Okay. Then we'll go for the just 2 minutes break, ma. Okay, 2-3 minutes break. You can take the 2-3 minutes break. Okay. Then we'll continue the class like this. Take a break. Then we'll go for the next one. So it will be like that only.